Hey there, welcome back to another video. In the previous video, we implemented this fraction class and we added functionality for addition, subtraction, multiplication, and division. Now, I want to expand on the multiplication because what we did was when we multiply two fractions, we could just directly multiply the numerator and the denominator. So for instance, if I had 3/4 times 2/7, this would be 3 times 2 over 4 times 7. Which is 6/28. Now what I want to do is I want to expand the support for integers. Because we're working with numbers here, it'd be convenient if I could multiply a fraction with an integer as well. So if I did 3/4 times 3, I would get 9/4. And if I did 3 times 3/4, I would get 9/4. So I want to be able to do this, and multiplication is pretty useful. Whenever we multiply a string or a list, so for instance, if I had a string ABC, if I multiply this by 3, I would get ABC, ABC, ABC. And if I did the other way around, I would get the same thing. But if I try to take a string and subtract an integer from it, it will not work. It will only work if I multiply. The same thing applies if I had a list. So if I had list of 0 times 3, this would be 0, 0, 0. And then if I flip it, 3 times list of 0, I would get the same. So why don't we implement our multiplication? Now I have some example here. So if I had a fraction with 3 and 4 for numerator and denominator, if I did a times 3, I want this to call mul. But you see, mul takes in other, which is another fraction, so it's other.numerator and other.denominator. So if I did a times 3, I would get 9/4. That's what we want to return. And just to reiterate, when I do a times 3, this is saying a dot mul 3. So we're passing in a for self here, and 3 is other. And if I had another fraction that was b, this would be a times b, okay? And if I did b times a, that would be b dot mul a, all right? To modify this, we have to check the type. So if this instance, other int, so if we're passing in an integer, we want to return a new fraction, self.numerator times other, with other being an integer. So if it's an integer, we just do numerator times that integer, and we keep denominator the same. So now if I run my program, we get 3/4 and 9/4. When I do a and then a times 3 for b, we get 3/4 and 9/4. So now I want to be able to apply this the other way around. So I want to do 3 times a. So let's try to do that. And if I run my program, you see that there is an error, and it's saying unsupported operand type for multiplication with int and fraction. So how can we fix this? Why is this error popping up? Well, we're saying 3 times a. What does this mean? This is 3 dot mul a. So we're passing in a fraction to multiply with an integer. We're calling the integer's multiplication operator, not the fraction multiplication operator like we did here. So we would have to implement another operator called Rmul. And Rmul means right-hand side multiplication. So over here, this is left-hand side multiplication. So we're doing a dot mul 3, which is fine because we did our type checking here for integer. But over here, we're doing the other way around. We're calling 3's multiplication operator. So what this Rmul does is it's saying, okay, so 3 times a, 3 does not support fractions because fractions is something we made up ourselves. However, if we had Rmul, what this does is it'll say, okay, if this does not work, I will try calling the Rmul method from a. So over here, we'll just do self times other, so that self times other would call this. It would call self dot mul other, like that. So we're going to return this, and if I run it, we now see 3/4 9/4, 3/4 9/4. So with this integer, it's saying integer times fraction is not compatible. However, see if fraction has Rmul overloaded so that I can call that instead. So right hand side multiplication. All right, that's the difference between the two. And I also want to show you something very interesting in that there's this naming issue that I had earlier. I'm not sure why it worked for a while until I learned something new, and that is if I took that away and I ran my code, it would work. Can you figure out why this works even though I did not check for the other type? So if you kind of had some idea, you would say, oh, maybe integer, which I pass in as other, has a field numerator and denominator. So let's see what happens if I print help int.numerator. And then let's do the same thing for denominator. And if I run this, the built-in integer type has a numerator field as well as a denominator field. So it had to do with my naming, which is why it worked. I was confused for a while when I was testing my code. I was like, why is it working? But apparently, as you can see, integer has a numerator and denominator. So if I were to change numerator to a different name and call it numer, so let's do that and run my code. So let's get rid of these two. So same code, I just changed numerator to numer and I run it. You can see now int object has no attribute numer. Okay? So it had to do with some naming issue, which is causing some behavior that I did not expect. So if I undid that, okay, so if I run my code now, we get 3/4 and 9/4. All right, so just to be safe, you should never assume that the other type has a certain name or field. So you should always add is instance other int, and then let's just fix this. Okay, so that's Rmul and Rmul, and I hope you enjoyed the video, and I'll see you in the next one. See ya.